All right, ladies and gentlemen, in this video we are opening up our discussion of circles in the coordinate plane. The overall goal of this section is to be able to write and graph equations of circles and write a coordinate proof at some point and solve some real-world application. Specifically in this video, we are going to be focusing on our success criteria of knowing what the standard equation for a circle is. We're going to kind of derive it a little bit. We're going to use it to find the radius and use it to find the standard equation of a circle to find the center. And we're going to go ahead and focus on writing an equation of a circle just in standard form, not by completing the square yet. Okay, not by completing the square yet. We'll get there though. So let's see kind of where our standard equation actually comes from. Well, let me just draw a circle real quick, and I'm going to have the center of my circle at the origin. All right, I'm going to have my center at the origin. So let's just think about what happens in this particular example. Let's just choose a point on the circle. I just choose a point on that circle. We all would agree that that point is just some x value and some y value, right? That's all it is. It's some x value and it's some y value. Okay? And so the distance from this point, the x-axis, there's my x-axis, there's my y-axis, the distance from this point to the x-axis, is a value of y, and the distance, all right, from this point specifically to where it reaches, all right, is whatever the distance of x was from the origin. So from the origin, right here, is a distance of whatever that x value actually was. Well, let's think about this now. Now, what did we create? Well, we of course created a right angle in there, and then what ends up happening? Well, if our center is our origin, I create the radius as the hypotenuse of this right triangle by this any point that happens to be on the circle. And so we go ahead and think about this for a sec. The center point is just 0, 0. So it just keeps and holds suit that the distance is x and the distance is y. And so the center, or the equation for this type of circle, is just going to be x squared plus y squared. And then think about it. What does our Pythagorean theorem say? A squared plus b squared equals c squared. And so a squared x, b squared y, r squared c. And so this is kind of where the standard equation of the circle stems from. And the only way it really changes is what happens if we shift it away from the origin. Well, if we shift it away from the origin, we have to take into account the changes that we have horizontally and the changes that we have vertically. So what we end up seeing here is the standard equation of a circle is just x minus h quantity squared plus y minus k quantity squared equals r squared. Okay? This is all just stemming from our Pythagorean theorem. But we have to account for the change in horizontal and vertical shifts from the center origin. And that's what HK represents. HK is going to represent the center of our circle. HK is going to represent the center of our circle. But notice here, the standard equation is x minus h, y minus k. Why is that significant? Because that means it's the opposite of what you see. It's the opposite of what you see if you're identifying the center. Okay? And of course, r is going to be our radius, as we just found, utilizing our Pythagorean theorem. So let's take a look here. Write the standard equation of each circle. So let's go ahead and find the standard equation of this circle. Well, we see here that the center of the circle is going to be at the origin. How do I know that? Well, because there's a distance of 3 in every single direction, and so that means the radius is going to be 3. So I will have x squared plus y squared simply equals 3 squared, which of course is 9. Okay? So we have our radius of 3 right in here, 1, 2, and 3. I knew the center was at the origin because it's 3 in all directions. And since the center is at the origin, 0, 0, when you add 0 or subtract 0 to x, it makes no difference. Subtract or add 0 to y, it makes no difference at all either. All right, so then for part B, we want to go ahead and draw or write the standard equation of a circle. If the center, so hk, so remember it's x minus h quantity squared plus y minus k quantity squared equals r squared. Well, 0 is my h, -9 is my k, and again, it's opposite of what you see in either direction. Well, -0 is just 0, so x squared, plus y minus a -9 is a positive 9 squared, and then 4.2 squared, and 4.2 squared is going to end up being 17.64. Okay, so 17.64 for 4.2 squared there. So that's kind of the basic version of how do we use the standard equation of a circle just by basic identification.